We're going to try to record this class. It is January 28th. It's a Monday. I am recording the math workshop only because it reviews what we did last week. So last week, the first thing we had to do was find the volume of a rectangular prism. We learned that the formula is volume equals length times width times height. I will say, we didn't do any that had, or we may have done one, but not many, that had kind of like a tricker number. If two of the sides are the same, guys, just ignore it. You need three numbers. You need a length, a width, and a height. Okay, so V is what I'm looking for. I'm going to say my height is 5. My width is 10. And my length is 4. But to be honest, it doesn't matter what order you have them in. In the end, we should all get 200. Volume is always cubed, or to the third power, because it is three numbers you're working with. You're thinking about cubes, like how many of these blocks fit inside some. It's a three-dimensional shape. So it is always cubed. Just kind of refreshing from last week, that's all. Because this will be on this Friday's test. Okay. The second one, number 2, says, and this is the trickier stuff. It says, find the missing measurement of a rectangular prism if the volume is this, the length is that, and the height is that. Well, what that means is you got to think like rectangular prism. Okay, the formula is volume equals length times width times height. So first you got to know that. Take what they give you and fill it in. My volume is 819. My length is 9. And my height is 7. So what they have not given you is the width. So that's why my W is my variable. Now, clean up the math that's on the same side of the equal sign. We know 7 times 9 is 63. And I have a W. Bring down the 819. Now it turns out to be an equation or an algebra problem because our goal is to get this W all by itself. So 63 up against W means multiply. The opposite is divide. What we do to one side, we do to the other, and it is 13. I look back, and it is feet, and since it is just a width, it's what I call a boring measurement. It's not squared, it's not cubed, nothing like that. Okay, so those are the two concepts on Friday's volume part of the test. Kind of easy, pretty much, you know. Okay. Everybody good so far? Okay. What we're going to start doing today is finding surface area. We're basically going to be figuring out, like if you have a tissue box, and I'm kind of showing them a tissue box if it matters, that you're finding basically to me how much cardboard it takes to make the box. It's kind of weird. Before we figured out how much is inside the box. Now we're going to figure out the outside of it. We first need to, what I call, kind of review these shapes. They're three-dimensional shapes. It's not hard because we've kind of already done this. So you are going to want to fill this in with me. And then we'll get to the more mathematical part of it, I guess. I don't know. At least to me it's more mathematical. You're going to want a pencil. You're going to maybe want a highlighter later. I don't know. That's up to you. I'm going to do the best I can. Here we go. So, starting out this week, when you are finding surface area, we first have to be able to know what shape we're looking at and what I would call what the shape unfolds to. So first, we need to be able to look at them as a three-dimensional figure and say the name of it. Okay? So, like this one is a, slow down, what's the base? Rectangular pyramid comes to a point. So, this one is a rectangular pyramid because it comes to a point and the base is a rectangle. So the next one is a triangular. Comes to a point, so pyramid. These are the kinds we'll be finding surface area. This one is a cylinder. We don't do surface area with this yet because honestly the circle makes it a 7th grade standard. You learn all about circles in 7th grade. Okay, going down to the next one. Number 4, cone. And number 5, sphere. Okay, 6 is, okay. We normally call it a rectangular pyramid, but this one you could also call a square pyramid. Either one. You can call it rectangular, which is what my morning class, ULAR, or square pyramid. Doesn't matter. I would take either answer, rectangular or square pyramid. Okay. And question? No. Okay. 7. The ends are what? Triangle. So it's a triangular. When they're flat on each end, they're called prisms. Triangular prism. Those flat ends make prisms. Okay, 8 is a rectangular prism. And 9, cube. If you called it a square prism, I would probably count it right, just because we keep naming prisms. But that is a cube. Okay, now, as you can see, looking at the right side of this worksheet, okay, these things are called nets. It has a fancy name of a net. Now, I'm going to be honest. If you think about fishing nets, if you've ever seen one of those shows or whatever, and you think about they're out there in the middle of the ocean and they're putting out these gigantic nets. And when they drop them off the back of the boat, they start out like in a ball. And eventually they open up and they kind of catch all the fish before they roll them back up and get them on the boat. So, a net is taking a shape and basically unfolding it. The reason this helps is because you're not, let me just be honest. I'm going to walk over here and show something which is kind of scary. These are the formulas that I grew up with. And yes, I'm old. But these formulas basically almost made it a little more hard, I think, because you had to memorize another formula, okay? What we're going to do is take the shape opened up like a net, and we're going to find the area of each little shape, and we're going to add it together. It's the same thing as this. This was just harder. So I guess you say the way of teaching it has changed a little bit, which isn't bad. It isn't bad at all. But imagine cutting it. The weird thing is this. I might make this a cut, or the next time I cut it, this might be a flap. It just matters how the person cuts it. So what I'm talking about with the flap thing is like this one. Do you see how that flap is right there? Yes. Okay, those two flaps right there could be up here. It doesn't matter. It's the same shape. Does that make sense? Like those two flaps could be down here. Wouldn't matter. It'd be the same shape. So as we look at these things, different people draw them different ways is all I'm saying. Okay? Okay? And what I'll do, tomorrow I'm going to have a bunch of these kind of like hopefully cut out, and I'll show you some different folds and just weird things. Okay, so look at it, number 1. I bet you already know what this is. But listen, what on the other page? Cylinder, yes, it is a cylinder, unfolded. It has 2 circles, and if you slice the cylinder, you'd have a rectangle. Okay, and I'm going to kind of go across. I wish that this circle was kind of attached down here, but it's not. It is a what? Cone. Doesn't matter, attached or not, the same thing. Okay. Going down to this one, which is officially number 2. It is a cube. Okay, on this one, look at the base. It is a triangular pyramid. It's going to come to a point because those little ends are all going to fold up. Triangular pyramid. Okay. This one, number 3 down here, is a what's the base? What's the base? Square rectangular pyramid. It's going to come up to a point. These little sides would all fold up to make a point. So you could call it a square or rectangular pyramid. You can just put one. I just show them both of them. Okay. I realize that 7 kind of looks like a cube, but it's not. It's a what? Rectangular prism. The ends would be flat. These 2 ends would be flat, so that's fine. Okay, and this number 4, the ends are triangles, so it's triangular prism. And the last one, rectangular pyramid. It's going to come to a point. Oops, I ran out of room on that one. Pyramid. Okay, so that is just showing like they're all made of either a circle, a rectangle, or a triangle. Except the cone's kind of made of something else, but that's okay. Luckily, we are only dealing with the shapes on the back. Flip it over. Okay. Basically, if you look at these shapes, it doesn't matter which one we're doing. And if you look at all 4, they are all either what shape or what shape? Squares. Squares. That sounded southern, didn't it? Squares. Rectangles. Or triangles, right. So they're either making pyramids or prisms. The reason I'm saying that is we're now going to find surface area. This is where all the math comes in, as I call it, okay? We're now going to figure out, like, how much cardboard the box is, okay? Here's the thing. If you look at that sheet, you are seeing that it's only basically like rectangles, squares, or triangles. Thank goodness. Because I said 2 weeks ago, we got to keep these formulas in our head. This is area. We already know the area formulas. Listen, what is the formula? And I'm going to write it right up here. The formula for a square or a rectangle. What is it for area? BH, right. A equals BH. We're going to use that thing. If you don't know it, write it down. But you've already had a test on it. Okay, and the triangle is A equals BH divided by 2. Listen, if you don't have these memorized for some reason, you have to this Friday. This will not be I'm not going to correct your test till you make 100 thing. We got to see what you know by this Friday, okay? And that is big time. Okay, so now, I'm going to show you how to kind of go through one of these shapes. It's kind of weird. Takes some writing. Are we ready? Okay, so looking at number 1. I'm going to do just one at a time. Here we go. Okay, looking at number 1. It's made of rectangles and triangles. Everybody agree? Okay. I personally start with the easy part first, which is the rectangle. Okay? And I need you to start seeing some things. When you look at this thing, okay, I'm looking at this rectangle. What is that wall? 11. So what is this wall? 11. What is this wall?
11.
And that wall?
11.
11. Do you see how they're the same going all the way across? Okay, because sometimes, you got to look at that stuff. Now, I want you to look at the other wall. What is that wall? 3. Now, the way you know it's 3 is from that little dash line. That little dash line is right there and right there. That means that all 3 are the same number 3. So once you think about it, that rectangle is a 3 by 11. The other wall. We got to think one wall times the other wall. So over here, I'm going to do my formula for the rectangle. Base times height. Yes, you have to write the formula, and you got to write it out. Okay, my base is 3. I'm going to say my height is 11. Doesn't really matter if you flip-flop them. I wouldn't be real worried. And it is 33 inches squared. Now, that is the area of this rectangle. Does everybody agree? But I want you to think about it. If this one's 11, how long was this wall right here? 3. Like this is the same as that. So that was a 3. So this is also a what? 33. If this one's 3, so is that one. So it is 33. Listen, it won't always be that way. We just got lucky on that one, okay? So, our 3 rectangles are all 33s. Everybody good on that one? Okay. We're going to go to triangle now. You got to kind of pick it apart. This triangle's formula would be A equals base times height divided by 2. Okay, triangle. I need a base, and I want you to notice something. You figured out that that base is 3 down here. So this wall is also 3. Do you see how I'm sliding it up? It is a 3, and then my height is 2.6. Okay. So 3 times 2 points divided by 2. I just don't remember, and I've done it 3 times today. You'd think I'd remember, but okay. Now it's 7.8 divided by 2. 3.9 inches squared, because it's area. Area is always squared. Okay. Now, I need you to kind of slow down a second. I want you to think about this. 3.9 is this triangle, and I know I'm out of room, so we're just kind of writing it, and this triangle. Once you think about it, surface area means all of it together. The surface of the shape added all together. 99, yep, 3 times 33 would be 99, plus 3.9 plus 3.9. What'd you get? Because listen, you got to add all this, which is 99, plus 3.9 plus 3.9, 106.8, and it is area. This is still area, so it's inches squared. Now, to give you a few hints, okay, to give you a few hints, I would put the big fat numbers in the middle, or maybe draw an arrow or something. The reason is, it helps the teacher to figure out where if you make a mistake. If you don't write the information guide, if you don't write the formulas, you don't write the numbers, you will not get credit. You will fail Friday's test. I am begging and pleading with you to do everything I'm doing in class today. Quit. Take it off. Put it up. Put it down. Listen, you need to stick up for yourself in your own math grade. Like, you need to. Yes? Surface area. I had to think of the words. SA means surface area. So, like, the top of the worksheet says it's surface area from nets. That's because we're using a net, like an unfolded object, and we're going to find all the surface area. So, honestly, I know I keep using this tissue box, but it's just easy. Surface area of this tissue box is literally how much cardboard did it take to make all the walls, including that if it was closed, okay? This is used, like, if you look at the one that's all little squares and stuff, if you're thinking about surface area, like anything you're trying to cover, for some reason something that just hit me was like upholstery, like when somebody's trying to cover a chair or cover something, they're figuring those things out. It might be a cardboard box, and how much cardboard is it going to take to cover something? Does that help a little bit? Kind of see it? It's SA means surface area, and then we're using a net, meaning it's all opened up. One day they may not be opened up for you. You may have to open them up. Used to be I had to teach how to draw all these things. Thank goodness we're not drawing anymore. But, okay. So let's look at number 2 here. Okay. First off, let's name the figure first this time. It is a pyramid, and what kind? The base is a triangle, so I'm going to say triangular pyramid. Okay. Now, looking at this thing, I see a bunch of triangles. I know the formula is base times height divided by 2. Okay. Now, this is the part that it worries me. Some of you may not be seeing. So please look real quick. That right here, like this is 7.2. And I think you all get that. But I need you to see that little dash line. That means wherever there is a 1 dash, they're all 7.2s. Okay? And I'm going to draw something just kind of silly, but look real quick. If you have some odd shape, let's say you have, and I'm just making something up here. Okay. I know it's weird. Just go with it. Okay. Here's the thing with geometry. And I know you don't know this yet, so I'm kind of showing you. Wherever they put, like if they put a 1 dash right here, and they put a 1 dash right here, they're wanting you to know that those are the same length. Let's say over here they put a 2, and they put a 2. That means those two are the same length. You got to just know that 2 dashes and 2 dashes are the same length. If they put 3, and maybe over here they put 3, that means those are the same length. They may not even look the same length, because in the world of geometry, not everything is drawn perfectly. You have to trust. So like, let's say that they said this is 5, then you're just supposed to know that's 5. Let's say this is 6, then you're just supposed to know that's 6. If they say this is 10, then you're just supposed to know that's 10. Because of the silly little dashy lines. I don't know what else to call them. But you'll see those a lot in geometry. We usually only see, like right here on this one, we only usually see 1. And that just means that one, and that one are all the same length. Does that help a little bit? Kind of? Okay. So, our base is 7.2, because that's our base. That's 7.2 right there. What's our height? 5. There's my height. And then divide by 2. Yes. Millimeters squared. Okay. Now kind of slow down for a second. It is 18, but what is 18? Okay, the triangle, like you said, this is the height, right? And that's the base. So we know this one's 18. Does this one have the same height? If it's a pyramid?
Yes.
Yes. Okay, what about that one? Yes. And listen, if these are all the same going around, that means that middle one is also 18. So in the end, we got to do 18 times what?
3.
How many 18s are we using? 4. Wait a minute. 18 times 4, guys. 72 millimeters squared. Surface area. So some of them have more math involved, and some may only have one formula. It matters what the shape is. Are we good? Okay. Looking at the next one. Okay. And listen, today's